All right, we'll go ahead and get started. Thank you, everybody, for coming today and sharing a bit of your Thursday afternoon to learn about building decision support tools with Shiny, another Love Data Week workshop. So I'm Andy Lyons, and I'm pleased to be here with you for the next couple hours. I'll put the link to our slides here in the chat window as well for anyone who's just come in. We will be doing some hands-on practice with Shiny using Posit Cloud. We'll be doing that probably maybe 20 or 30 minutes, not right away. But feel free to, if you don't already have a free account on Posit Cloud, go there and set one up. That will simplify things. If you are on RStudio desktop and you use RStudio and you're comfortable installing packages and that kind of thing, hang on, and I'll send you in a little bit, give you a link for a file, RStudio project file that you can download and open up in RStudio. All right. But otherwise, let's get going here. Got lots of stuff to talk about today. So this is part of UC Love Data Week. I hope you've enjoyed some of the other workshops as part of this workshop series. We've been doing this maybe 5 or 6 years now. I think it started during the COVID. But it's a really, really nice selection of workshops dealing with all kinds of things related to data. So real pleased to be part of this. And the recordings from many of these workshops are also going to be posted on the Love Data Week website. So keep checking that out. The UC Love Data Week organizers do have this code of conduct. The essence of it is you would just be nice to each other, and respect each other. We're all in the same boat, and we want everyone to gain something out of this. All right. So thank you for being a good neighbor and a good citizen of our Love Data Week workshops. Let me talk a little bit about myself and my group. Right. So I am part of the UC California system, but I work with the Division of Ag and Natural Resources, which is a part of the UC system that a lot of people don't know about. Most people are familiar with the 10 campuses, and we have several national labs, but this is a whole nother branch of UC. And in my opinion, it's the best branch because we consider ourselves the 11th campus because our students are all across California. They are the farmers, the natural resource managers, people who are working in nutrition and youth development. We have well over 1,000 people spread across the state, including clusters of faculty with joint appointments on 5 of the 10 UC campuses, which you can see highlighted in red here. The big ones are Davis, Berkeley, and Riverside. And newcomers to that group are Merced and Santa Cruz. So it's a growing campus footprint. These little blue dots you see here on the map are our county offices. So as you can see, we have well over 50 offices spread throughout California, where our researchers live and work with the communities they serve, doing all manner of interesting research and extension projects in agriculture and natural resources, water resources, community economic development, youth education. We have recently some new ag tech and bioenergy researchers. So really neat stuff. And then there's about 14 of these statewide programs and institutes, some of which you might have heard of, particularly if you grew up in a rural area in the US. 4-H is a popular youth education program. Master Gardeners is another one. I am part of this informatics and GIS group. And several of my colleagues are here. I'll shout them out here in a second. But we are basically a GIS shop with the privilege to support this whole network of people across the state and anything dealing with GIS, data science. We're building a lot of web applications these days. We fly drones, and this workshop is part of that. So if you're interested in applied work, I strongly encourage you to get to know this part of the UC system a little bit more. I didn't learn about this until I was basically halfway through grad school, but I'm real pleased and consider this a really fulfilling kind of work. All right. So I do have some of my colleagues here. I'm just gonna we won't do intros right now, but thanks to Shane, Robert, and Genoa for being with us today. And if you guys have any questions that come up, we're a small group. Go ahead and put your questions in the chat, or even unmute yourself and speak up. All right. So a little bit more about some of my work. I do work with R quite a bit, and as part of my job. And these are some of the R packages that I have developed. They tend to be focused around natural resources, climate, weather. I've got a curious one here that helps you manage your drone collections. So I really enjoy working with R and benefit from the vast ecosystem of R developers and programmers out there, and making some contributions here. If anyone's interested in this kind of stuff, I'll be happy to chat with you more about it. And then I also build Shiny apps, which is probably why you folks are here today. And I won't click on all of these. I'll click on one of them just to kind of give you an idea. If you haven't seen Shiny apps before, what they kind of look like in practice. As you can see in the list of my projects, most of them have the word calculator in them, which kind of gives you a hint that most of these are they're lightweight. So they're designed for a really kind of specific decision. In this case, what we're looking at here is how long to run the irrigation system, right? If you're an irrigator. And these calculators, they tend to be very focused. And as you can see, it's a really simple interface. And that's because most of the people who would use this kind of tool are going to be using it from a phone, right? But it's a very simple interface by intent. And here you can see this particular one. Let's say you're in Ventura County and you're growing strawberries and you got to turn on the sprinklers. So you put in a couple pieces of information here, what zone you're in. The last time we had some rain, let's say that was a week ago. So after you just click in 3 or 4 boxes and then click calculate, and what it's doing, it's going to get the local weather station data, do some number crunching. The number crunching is actually not trivial. It might seem like this is a really simple thing, but there's a lot of processing going on. And you click calculate and it says, okay, you should be running your sprinklers for about an hour. And if you were thinking to yourself, oh, I was going to run them for 4 hours, so let me look at this again, right? So this is just an example of a really simple calculator that was built fairly easily and quickly with Shiny, right? So I've got lots of little projects like that. And that's kind of the impetus for what we're talking about today, which is how we can use this to build decision support tools. About the people who signed up for this workshop, I think this probably represents a lot of Love Data Week in general. A great number of people. It looks like the top 3 campuses are going to be San Francisco, Davis, and Santa Barbara. So thank you for you folks for signing this up. But good portions from all the campuses actually. People who signed up for this workshop are mostly grad students and staff. So that seems appropriate. Working with R and data analysis and data science tends to be something a lot of people do in grad school and a staff. And then in terms of our experience, this is great to see that most people here have at least some experience, and quite a few people have quite a bit of experience who signed up for the workshop. So that is good. This is going to presume, that you've seen some R before, but even if you are rusty with R, hopefully this will be stuff that you can at least be familiar with. So let's jump to Shiny. What is Shiny? So I've heard it described different ways. Some folks one way to think about it might be it's a delivery vehicle for an R script, right? So R scripts, like scripts in general, are not something members of the general public are really going to know what to do with, right? So if you got some useful work that you've done and you've done it in R, Shiny is a way to get it to people. It's an R package that simplifies the process of creating web apps from R code, right? So I assume if you were an R user, you probably feel pretty comfortable writing R, but you're probably less comfortable developing web applications, as most of us are. That's a whole nother skill set, and people go to school for years, and that's the main focus of their day jobs. It's just web application development. So R makes that easier for people who aren't web application developers. Another way to think about it is as a web platform that allows you to create HTML pages with R components. So there are a couple keywords in there. Shiny applications are indeed web applications, and they're based on HTML. And furthermore, they do have components that were built from R. Right? So these are going to be some themes that we'll be seeing today. At a high level, right? So the way Shiny works is that you have your web page, right? So here's a little picture. This one looks like a dashboard, and it's a web page. It opens up in a browser, and it's got some interactive components. There's some things you can select. You've got these graphs, and the way this works is that web page is connected to a session of R that's running on a computer. Today, that might be your laptop. It could also be a server. And Shiny is basically the glue that connects these two together, right? So when you select something on the web page, that sends a command to the server that does some calculations and then sends the results back to the web page. So you can think of Shiny as an R package that allows a user interface that's in a browser to interact with R code that's on a laptop, and the result is a web application. Right. So what we're going to hope to get to today will be to understand how Shiny works. I'm really trying to, my hope is that you'll understand the principles and the fundamentals of how Shiny operates. I will also note, because I know there are some folks on here who are not really R users, but they're more Python users. The good news is that R or Shiny is fully supported by Python as well. So the code will look different in Python, and I'm not going to show any Python code, but at least the concepts and the basics and the fundamentals of how Shiny operates will be the same if you do want to work with Shiny in Python, as many people are doing. So part of that is we'll talk about the principles of reactivity. It is a different style of programming, right? So we'll talk a little bit about how that's different. You will absolutely be able to create a Shiny app from scratch. You'll be able to do that in about 10 minutes from now because we're about to do that. The hope of understanding the terminology, some of the basic principles, is that you will then be able to utilize the documentation on Shiny, of which there's, as you can imagine, tomes of it out there on the internet, as well as using GenAI tools. And we'll talk a little bit about what some of those tools are and how some best practices for using them. And then ultimately, we are working towards getting you to the ability to have a decision support model, whether that's really simple, like looking up a few numbers from a lookup table or something you might see in a spreadsheet, all the way to more complicated statistical regressions and giving it sort of a shiny front end as a web application. All right, so that's where we are going. Any questions? Okay, let's make a Shiny app. So go ahead. At this point, I'm going to kind of like live demo in RStudio. I'm going to go to RStudio Cloud, sorry, Deposit Cloud. Right, so I'm going to open up my new window here. I'm going to Deposit Cloud. You could do the same. So at this point, go to Deposit Cloud. And I will go ahead and put in the chat window a link for you to click on. Okay, so that link I put in the chat window, click on that, as I'm going to do here in my browser. And what that's going to do is it's going to prompt you to log into Posit Cloud if you are not already on Posit Cloud. And it's going to open up this project, right? If you are using RStudio on your laptop, just open that, and that'll be good for right now. But I'm going to wait for this RStudio to open in my Posit Cloud. And then the first thing you should do once it opens is you'll see up in the menu bar at the top there a red sign that says this is a temporary copy. So if you want to keep this in your Posit Cloud workspace, click the button next to it that says Save a Permanent Copy. And what that's going to do is it'll basically save a complete clone of this project in your Posit Cloud workspace. So you can come back to it tomorrow or the next day. All right. I will pause here for a couple minutes to let people catch up. So again, you should be in Posit Cloud right now. Click on that link I put in the chat window, and it's going to open up a copy of this project. Okay, so a few folks have opened up RStudio. I'm going to proceed. So RStudio, I'm going to assume everybody has used RStudio a little bit. And one of the nice things about RStudio is that they make it really easy to create new files from different templates, different types of files. So if you go to the File menu and then New File, and then come down and select Shiny Web App. All right, so File, New File, Shiny Web App. All right, and this works the same in RStudio Desktop. So give your application a name. I'm going to call this My First App. I don't know if spaces are allowed. I think they're not allowed. So no spaces. Basically, it's going to create a folder, and the folder is going to have this name. And that's it, right? So type in an application name for this new Shiny Web application and click Create. And if you look down there in your file pane, you'll see a new folder pop up. And then inside that folder that it just created is a file called app.R that it just created. All right. And the reason it's creating a folder for this app is because generally when you're going to publish your app on, on shinyapps.io or something like that, generally it publishes the whole folder, right? So in this case, we're not going to have any other files that we really need to publish with this app if we were going to publish it. But sometimes you might have a CSV file or some images or some other stuff, and you need to publish them all together, right? So that's why it creates a folder. So, but if you look at this app.R, I'm going to go ahead and close my console. So I'm just going to minimize it. And you might see in this app.R, we're going to walk through app.R here in a second, but let's just go ahead and run it and see what it looks like. So you might notice that, it is just plain R language, but there's this run app button in the toolbar. And before I run it, I'm going to click the little down arrow next to it and choose run in the viewer pane, right? You could also run it and, it'll open up in a new browser window or a new RStudio window, but running it in the viewer pane means when I click the run button, which I'll do next, it's going to open it up in the little viewer pane. All right, so I'm going to go ahead and now I have this live Shiny app. I'm going to go ahead and close my console again, and it is up and running in the viewer pane. So as you can see, what we have in this kind of hello world, this sample Shiny app, is a slider. And when I move the slider, that adjusts the number of the bin width of the histogram that's below. And it's using a data set that's kind of comes with R. It's a data set that shows the amount of time between eruptions of Old Faithful at one of our geysers in Yellowstone National Park. All right, so it's real simple, right? It's basically it has an input element, right? So that's what that slider is. It's an example of an input because it's something I can change. And then it has an output element, which in this case is the histogram, a plot. All right, so that's what it looks like when it's running. Let's look at the code that we just created to that. And this is something which, if you've worked with R a lot, this may or may not look familiar. So as we can see, it is an R script. We see the comments there. We see that the first thing that we're doing here is loading the Shiny package, which is necessary. And then right below that, you'll see we're defining this object called UI, right? So it's about 20 lines of code there. And UI stands for user interface. And this section of the script is defining exactly that, the user interface. And if you look at what's in there, we see some functions, title panel, sidebar layout. All of these functions are basically returning or generating HTML code, right? So this is the section of the app where we are defining the elements as well as the layout. Okay, so for example, let's say I wanted to, and you feel free to do this as well. Underneath that title panel, if I go to the top, if I scroll up to the top of the app, I can see that title panel. Maybe I'm going to, right below there, I'm going to type in here, I'll say P stands for paragraph, and then I'll say inside there, welcome to my app. All right. And then I could, you may also notice that all of the functions inside this fluid page function are arguments. So we have to separate them by commas. And now if I reload the app, and of course I have to have my script saved, I saved the script and then reload it. I can see now it added that little piece of static HTML. P stands for paragraph. All right. So that's essentially how it works, right? So that's the user interface. If you scroll further down below, and the next section of the script is called this, is we're setting up a function called server. And in this part of the app, this is where we define the interactivity, right? In this case, there's only one thing, there's only one kind of interactivity here, that there's a connection between that slider and the histogram. And we'll talk through more about how this works. But essentially, you can see in the server section, we're defining this object called output $displot. And if you look closely, displot, where does that come from? If you come up to the top, you'll see in the main panel, in the user interface section, there's a function called plot output. So this plot output function in the user interface, that's creating like a placeholder in the user interface, but it's empty until it's populated. And the way you populate it is through a function in the server section, which is using a function called render plot to basically throw a plot in there. All right. We're going to come back to this. I'm just trying to get you a little bit familiar with some of the general principles about how we set up this interactivity. All right. And then finally, at the very end of here is just is another function that actually launches the app using the objects we created above. Right. So this is a classic template for creating a Shiny app. All right. Something else you might notice if you do open your console here is that it's gone, right? I can't type anything here. And this is because when you are running a Shiny app, it requires an R instance, which basically means I can no longer use my console. I can no longer evaluate commands. I can still, type in the script window, but until I hit that stop sign, I can hit that stop sign to kind of stop the app. But and then the app closes. But when you are running a Shiny app, it does require an R instance, and if you're using it on your laptop, it's going to use your RStudio R instance. Of course, you can open up another copy of RStudio, but that makes sense, right? Because the way this works is that there has to be a session of R that's running in the background. Okay, any questions? All right, so real quickly there, that was a little bit about how it works. I'm going to go ahead and again, this is kind of a teaser, right, to show you how we can modify. Because a good way to learn programming is to take something that works like this and then tweak it. All right, so I'm going to tweak it. You can try to type along with me if you'd like. Otherwise, you could also just watch. But let's say when I run this, suppose I wanted to give the user the ability to change the color of those histogram bars, right? Well, I know that there is in this hist function that we're using, which again is from base R. There's an argument that we could use called color. Okay, so we can see that call argument is right now it says dark gray. If I retype that and ran it again, of course it's going to produce red. Now, what if I wanted that color to be something that the user can change? So the way I could do that, again, I'm going to stop it here. If I come up to my user interface section, there's a slider input. So right below that slider input, I'm going to put in a drop-down box where the user could pick a different color. All right. So to put in another user input, I'm going to, first of all, I have to put a comma in after slider input because you always got to get your commas right. And then the function to put in a drop-down box is called select input. And then let's look at the arguments that we need to put in this function. So we can see from that little tooltip text, input ID is going to be required, label is going to be required, and choices is going to be required. So those three arguments are going to be required. Everything else has a default value. So for the input ID, I can just put maybe, I like to name my inputs with IN underscore. It just kind of helps me remember what they are. We'll just call it in color. All right. The next argument is label. So I'll just put here color. That's going to here as the label. And then for choices, I basically have to tell it, give it a vector of colored named colors would work here. And I know there's a base R function called colors. Color choices equals to colors. And I think that gives you, yeah, that returns like, what do we got here? Like 658 named colors that R supports. Okay, so now let me go ahead and run this, hit save and run this. So I see this color box, this drop down. So the last thing I need to do is kind of connect it to the plot or to use its value in the histogram function. All right, so I'll go ahead and stop. I'll go ahead and put this in the chat window if anybody's wants to do that. So if you want to try this, the select input function that I just put in the chat window, just paste it below the slider input function. And then next I'm going to come down to the server section, and we're setting up the value of the call argument. Instead of giving it a literal value, I'm going to put in here input $, and then so input $, that's how you get access to the values of all your input elements, right? Use the input $, and then you have to give it the ID, which I think I called in underscore color. All right. So let's give that a shot. So I'm going to I saved it, hit run, and this is looking good. It's the initial color is white because that's the first one. So, but if I change the drop down to something else, indeed it does change the color. All right. So that's just a quick example of how you can add an input element and then use it somewhere else in your app. In this case, we're using it as one of the arguments for the histogram function. All right, any questions? I'll put that revised histogram function here in chat as well, if anybody wants to try it out. One thing I like about RStudio is that you can, if you copy paste something from the clipboard into your code, it gets all of the indentation and the spacing right, which is pretty neat. Okay, let's go back to these slides then. So we've just created our first Shiny app. And let's review what we just went through, right? So we just saw that Shiny app is our code. There's nothing different than that. It's usually saved or stored in a single file called app.R. You can separate the server and the UI into different scripts, but most of the time they're just together in a single file called app.R. And that file is usually saved in a folder with anything else that you might need when you publish your app. Okay. So, but that app.R, as we just saw, this is a little bit different. It's not a typical R script, right? So let's take a step back here and think about what's going on, how this app is making that web app. So traditionally, if you've worked with R for data analysis, you've probably written lots and lots of scripts that look like this, right? So it's kind of runs from the top down. You load your libraries, you import some data, maybe you do a little wrangling with it, and then you work your way down and you do some visualization or some analysis, you write some reports. You might have some loops in there. You might have some if-then kinds of statements, but basically it's linear, right? You're going from top down. So that's kind of your traditional script, whether it's R or any other language, right? But web applications are different, right? Here's an example of a web application. So that model of a linear script is not going to cut it, right? Because most of the time, nothing's happening, right? Most of the time, this app is just kind of sitting there waiting for something to happen. So the way we program web applications, whether you're using Shiny or some other language, is we basically have a different approach where the various objects, the various elements on the web application, on the user interface, we create objects that represents those. All right. So here we can see for this app that we just built, we had a slider input, a select input, and then a plot output, right? So again, those were all saved in the user interface section of our code. Then the other thing we're going to need here is we need to define the interactivity between, again, these input and these output elements. And that's what these blue arrows represent. And that's interactivity. These blue arrows, they were set up in the server section when we wrote that little snippet of code that created this plot, right? Using values from the two inputs. And that's basically the essence of it. Shiny takes care of the rest. So when this is published and running, Shiny is just going to, the Shiny server will simply wait for something to happen for the user to, interact with one of the input controls and then take the necessary action, which in this case would be updating other stuff. So the code that we're creating doesn't have to worry about that. All it has to do is set up these inputs and outputs and then the relationships between them. All right. So this is basically the same for any kind of application programming where you've got a user interface that's where there's interactivity going on. All right. So as we saw with the Yellowstone Old Faithful app, there are 4 parts to a Shiny app, right? At the top is what I like to call the preamble, right? So this is where you load your packages, you load data generally. This is essentially populating your global environment, right? So anything, any package, any objects that we create at the top of our apps or Shiny app script they'll be stored in your global environment and they'll be available everywhere else in your application, right? The next section is where we define the user interface. And again, that's the elements, where they're located, how they appear. We're not really customizing anything here, but you certainly can. The third section of your script will be that server logic, right? And again, those are the blue arrows. And this is where we basically define how output objects are created. And then later on, we'll see some other examples of sort of intermediate objects that you can create in your server section. And then finally, a command at the end to run the app. All right, so that's kind of the anatomy of an app. And then everything we're going to be doing onwards is simply, building upon this. Another difference between traditional R programming and building web applications is that you have an ally. CSS and HTML are really, really well-developed languages. The browsers know how to work with them, and they can do a lot of the heavy lifting, right? So, yeah, and the nice thing about Shiny is you don't really need to know all that much about HTML and CSS because it's got all these functions like title panel and paragraph and H1 to make a heading that will return valid HTML syntax, right? So all you need to know is how to use some of these functions, and it'll take care of the rest. So between Shiny and a package called HTML tools, there are dozens. There are like well over 100 functions that will generate HTML code. Here's an example of what that might look like in your R script. As you can see, there's a function called P, which is a subset of the tags. There's a whole bunch of them saved under tags. And basically, this is your R code, and this is how it renders on your web page. It renders as nice looking HTML text where you've got a hyperlink, right? So if you want a hyperlink, you use this A function, which creates the A tag in HTML, but you don't need to worry about that. All right. So we're not going to do a lot of this here, but generating static HTML, you can use all of these functions to do it from within R. If you do know CSS, you certainly can take advantage of that as well. Okay, any questions? All right, so we're going to do our next exercise. I'll go back to our studio here in a second, but this is what we're going to build. We're going to build the Penguin Data Explorer. This is what's going to look like when we're all done. We're going to start from scratch. As you can see, there's going to be one input element, and that's going to be one of these select boxes where you drop down and there'll be the names of the penguins species. What we're going to be plotting here. There's a data set called penguins. And it's now part of base R. It used to be part of the Palmer Penguins package. It's basically body measurements of penguins that some researchers collected for their research. And then there's going to be, in this app we're building, there's going to be two outputs this time. There's going to be the scatter plot, which we'll create with ggplot, and then there's going to be a little table, a little summary table, which we'll make with dplyr. Okay? So that's what we're going to build. So if you are using RStudio Desktop, I'm going to put a command in here called use this command. So if you're using Posit Cloud, just go back to Posit Cloud, and we'll keep working there. I'm going to keep working on Posit Cloud. But if you are using RStudio Desktop on your laptop, you can run that command that I just put into the chat window, or you can just simply click on the URL there. That's going to download a zip file. You unzip it, and then you'll see there's an rproj file inside there. Double click on that rproj file, and it's going to open that up. Right? It's the same project that we're working with in Posit Cloud. Okay, so I'm going to go back to RStudio and Posit Cloud, and I'm going to close what I was working on before, and I'm going to go into the Files pane, and then I'm going to navigate to Exercise Part 1, and then inside Exercise Part 1 folder, you will see a file called Exercise App1 Start. All right, so that's the start of this exercise that we're going to do right now. All right. And when you open up Exercise App1 _ start, you might notice that it's blank. Well, that's because we're starting from scratch. All right. Okay, so I'm going to proceed. I'm going to assume folks are keeping up. If anybody is hitting a bump, please speak up. We'll pause and get through it. Okay, so this is we've got this R script that's completely empty. So let's go ahead and populate it with, now I could start typing, library shiny and then the UI, but RStudio has a little shortcut. So in your script window, if you type shiny app, and then I think Shift Tab. So type the word shiny app, no space, and then immediately hit Shift Tab, and then that's going to put in this kind of getting started code for a brand new shiny app. So let's proceed. Okay, so the first thing we're going to do here is put in the title panel, right? So you might remember a title panel is a function that we can use to create part of the user interface. So inside the fluid page function, that fluid page function kind of sets up a container for the entire user interface. I'm going to type here in your title panel. And if you type slowly, then the pop-up text will pull it up. And then simply the only thing we'll type in here will be the text that will appear in that title panel. And I'm going to put in here Penguin Data Explorer. I can type properly, right? And if you want to see if you're doing it right, you can simply save your script, Control S, and then click Run App. Make sure it's going to show in the viewer pane. And when I run it, indeed, I see my title panel with the title that I just gave it. Okay. Next, so let's see. We need, if you're not familiar, if it's been a little while since you saw the Penguins data set, I'm going to come down here to my console and just type head penguins, right? So head will show you the first few rows of anything. And penguins, again, is that built-in data frame. So I can see here, this is what it looks like. So we've got columns for species, for island, and then the 4 body part measurements, the bill length, the bill depth, the flipper length, the body mass, sex, and year. All right. So the next thing we're going to do is let's put in so underneath the title panel, let's create that layout where you've got a sidebar where you have all your input controls and then a main panel where the outputs are going to go. So to create that layout, there's 2 functions we're going to use. The first one's called sidebar layout, right? So that pops up, and then I hit enter to kind of set that up. And then I'm going to put this in chat here in a second. So if you don't want to type that, that's fine. So we've got sidebar layout, and then inside there, that's kind of the parent, and then we need sidebar panel, right? So that's going to be that side panel. And then a comma, and then main panel. Main panel. All right, so I will put this in the chat. Okay, so if you take what I put there in chat and you paste it below title panel, it should pop into place. So now we have the sections of our, so those functions we were using are kind of setting up the layout. Inside the sidebar panel, we're going to need a input box, right? That's going to be the drop-down box where they're going to select one of the penguin species. So what that's going to look like, we've seen this before. It's a select input. That's how you create a drop-down box. So I'm going to put in here select input. And then the ID, I'm going to call it in_species. Okay, the next argument is the label. So I'll name this one, say label equals to species. And then finally choices equals to, so the way I can do this, I can say unique. And then penguin species. All right. All right. Let me put this in chat here. So if you do want to put in the select input box, I think this will work, right? So unique simply returns the unique values of the species column from the penguin's data frame. Hit Control S and run that. And yep, so now we see a drop-down box with the penguins, the 3 penguin species in here. So in the main panel, we're going to have that plot. But before we put the plot in here, let's go ahead and just make sure that our app is working properly. Before we go ahead and put in a plot, I'm going to put in a text box, right? So inside the main panel section, I'm going to create a text output. So text output. Text output is basically a placeholder for for text that's going to be generated on the fly dynamically. And I'm going to call this, the ID I'm going to give it will be out_species. Okay, so let me go ahead and save that and run it. And looking good so far. I'll put this in the chat window in case anybody wants to follow along. Now, when I change the species, that's working fine, but I'm not seeing the name of the species in that text output that I just created. It is there. If I went to view source, you would actually see it's something there, but we're not seeing it because we haven't set it up to be connected to the select input, right? We haven't typed anything in the server section that links this output placeholder with the value of the input. All right, so let me go ahead and hit the stop sign. Come down to the server function, server section, and then here I'm going to create a little snippet of code, basically a recipe for how it should fill in that text box that I just entered. And the way that's going to look like, so in the same way that we were able to access the input elements using input $, we're going to access the output elements that we've already set up using output $. All right, which as you can see, there are going to be, those are arguments to the server function. So output $, and then now I put in the ID value that I just gave it, which in this case would be out_species. All right, so that's how we access the output element, the placeholder, and we're going to feed that or assign it to the results of a function called render text. All right. So every output element has a corresponding function that starts with render that you use to kind of populate it dynamically. All right. So and I'm going to go ahead and put in curly braces inside my render text function. I'm not going to need them in this case, but it's generally good practice to use those curly braces because then you can have multiple lines of code. And as long as the last one returns, in this case, a character object, then you're good to go. So, but as you can probably guess by now, if we want this output text box to include to show the name of the selected penguin species, we're going to put an input $, and then what was it, in_species. All right, put this in the chat window. So if you're following along, you can just copy what I put there in chat window into your server section. Let me go ahead and hit Control+S to save this and then run it. And now I can see when I do select the different species, indeed, that value is showing up inside that text output element. All right. So we've got a basically functioning app working right now. So next, let's go ahead and let's add a little static text because right now all you were seeing was the name of the species that were selected, and it was just kind of like hanging there in midair. It's like, what was it for? So back in my user element, my user interface section, right above the text output object, I'm going to put in, I'll use H3. H3 is going to insert a heading 3, a level 3 heading. And this is static HTML, right? We'll call this selected species, all right? Just to give a little context. So I hit Control+S again, run it again, and now that looks a little bit better. So it's basically telling me what species has been selected. Okay, any questions? I'll put that there in the chat as well. Oops. Okay, so we have okay, the famous mismatched brackets. Give me a second here. Yeah, so without diving into the details of that missing parentheses or missing space, this is common, right? So One thing just a general good practice with programming is as you type and always you type a function, make sure when by default when you type in a opening parentheses, R will parrot on your behalf, so it'll throw in that second one. That's almost always a good thing. Um, I would just say, as you're typing, every time you've typed in a line, just pause for a second. And if you see those little X's on the side, it means something's not matching up, right? And again, it's either a missing comma most of the time or unmatched parentheses. Those are really, really common, especially with these kind of like shiny programming where you've got lots of these, functions and functions that are entered as arguments and that kind of stuff. So, okay. Let's keep going. All right, so next, let's go ahead and add the plot, right? So let me go ahead and stop my Shiny app from running. So we want a plot to appear. So let's go ahead. The first thing we'll do is we'll create a placeholder where that plot will go. So again, I'm still in the main panel section. The function that will create a placeholder to hold a plot, you can probably guess is called plot output. All right, so put plot output. Now I can see when I typed plot output, there's a little red X on line 16, and that's because I'm entering a new um, argument to this function, which means I have to put a parentheses, sorry, a comma before the other one. Right. Okay, so that little red X is gone. So the plot output, the only argument you really require for all of your input and output elements is an ID value, right? So the argument for plot output, again, I'm going to name it out underscore, just to remind myself that this element is an output element. And I'm going to call this, we'll call it penguin scatter plot. All right. You can name it anything you want. All right. So that's good. We got an output element ready to go for it. And we're going to populate it with using a function called render plot. So down here in the server, I'm going to go ahead and just paste this in because it's a little ggplot and dplyr here. I'm going to paste it in here and then give it to you guys in the chat window, just to save up a little bit of time. All right. So what I put in the chat window is going to be a little snippet of code to stick in your server section, and you can delete there's some blank lines in there. Get rid of those. But let's take a look at it. So basically we're populating that plot output element that we just set up, and we're feeding it or we're assigning it the results of render plot, right? So render plot is the function that you use to fill plot objects or plot elements. And what the code that you put inside render plot needs to return is a valid plot object. That could be ggplot, or it could be a plot from base R. In this case, we're using ggplot. So as you can see in this case, there's actually two expressions in here. The first one is filtering the penguins data set using the filter function from dplyr. All right, so hopefully that's familiar. If you're not familiar with dplyr and filtering, just take it for face value that this is how you basically can filter a data frame based on a value of a column. And that's creating an object called filter underscore filt. And then basically we're using that in the next expression that's inside here, which is a ggplot expression. Now, I could go ahead and save this and run this, but if you're astute, we expect there's going to be an error here when I run it. And indeed, there is an error because we haven't actually loaded dplyr or ggplot. So let's go ahead up to the very top of the tippy top of the script, and let's load using library functions. We're going to load ggplot2, and dplyr, because we're using the functions from those packages. Dplyr. All right. You guys spelled that wrong. Dplyr, there we go. Okay. And then I also got another, well, let's go ahead and run this. And then there was another error I was getting here. Let's run it. Stop it and then run. Oh, it did work. Okay. Okay, so that seems to have worked. Okay, so once again, what we just did there was we put in a snippet of code, which I put there in the chat window, that will populate the plot output element whenever the user selects a different value of from the species dropdown window, right? So you'll notice all we have to do is type in an expression, in this case for a render plot, and because this expression, that this code in render plot has input $ in species, then Shiny figures out that whenever the value of the in_species input changes, then it's going to automatically update the plot, right? So those blue lines will, the arrows that are connecting those, it kind of infers those based on the code that you write in your server section. Okay. Next, so now we have a nice little plot here. Let's go ahead and quickly put in the summary statistics table, right? So we have a scatter plot that shows the flipper length and the body mass, and as expected, right? So when heavier penguins, they need bigger flippers to stay stable. So we're seeing kind of an upward trend. And we also see that the males are bigger than the females, which I guess that's something for penguins. So, but let's go ahead and underneath that, we'll write a little table. So we'll create a table output, and the table output will include some summary stats. So I'm gonna, just to speed things up here, I'm going to put into the chat window the code that we're going to use to add this table, right? So just like we did before, let's go ahead and put a placeholder element to hold the table. So I scroll up to main panel section, and then right under that plot, I type a comma there, and then I'm going to paste in what I just put there in the chat window. So I'm going to paste in, again, another heading that's generate static HTML, and then setting up a placeholder for a table using table output, right? So that's one of those functions. And then the server logic, again, I'm going to put here in the chat window. So that little snippet of code I just put in there, obviously you should probably figured out that that should go down in the server section, right? So come down to the server section, and these blank lines are not helping me. Okay, there we go. And then somewhere, the order in which you put things in the server section doesn't really matter, right? Because again, all you're doing is creating those relationships between the inputs and outputs, and then the order generally doesn't matter. All right. So if you look at the code there that we put in the output, it's basically, again, taking the penguins, we're filtering it by the species, and then we're using group by and summarize. Those are two functions from dplyr that's going to group the rows by sex. And then for each unique value of that, it's going to create columns for the number of records, and then the mean flipper length and the mean body mass. Okay. Details aren't important here, but let's cross our fingers, and I'm going to hit stop and then run my app again. And let's see if this works. So if I scroll down, yes. So if I scroll down, I do see this summary statistics table, right? We did not have to load any new packages for this table because we're just using dplyr, which we already got loaded up last night. Okay, any questions? So this kind of illustrates the flow of building a Shiny app, right? So you do it little by little. You save it, you run it, you add something else, save it and run it. Generally do the user interface first, then, and then put in the server logic. This is a typical workflow. As you can see, we're not doing any customization. We're leaving like just the plain appearances. We're not playing with the fonts or the colors. Typically, I would do all of that stuff at the end anyway, right? So just get it working and then make it look beautiful. All right. Let's see how we going there. We're doing good. Okay. All right. So congratulations. You just created a fairly decent uh, app. Why don't we take a little break, right? Because this might hurt some people's heads. Let's take a 6-minute break and we'll come back at 3:15. Okay, let's keep going then. So I'm back at the slides here and uh, let's just kind of debrief quickly what we just did in that little exercise, right? So we basically created from scratch a new Shiny app, and this is the reactivity diagram. So again, one input and two outputs, right? So one select input and then a plot output and a table output. And then we wrote code in the server section to create those blue arrows, right? To create the links between these. This is a little bit simplified. It's not quite this simplified, but this is pretty close. We also saw some functions that we use to create static elements of the user interface. So here's a sample of these. Strong, this will make text bold. EM, this will make text italics. IMG, that's how you add an image file, right? So if you have an image file, if you do add an image file, which we're not going to do today, but if you want to do that, all you have to do is create a subfolder in your Shiny application folder and call it www, right? And then stick that PNG file inside there or that JPEG. And then when you use this image function, you don't have to put a path, right? That when it runs, all of the assets, all the files in that www file are kind of become at the root. So when you're trying to load them with image or stuff like that, you can put them there. BR creates a new line. HR creates a horizontal rule. Div creates boxes. We're not going to go much depth here, but there's lots and lots of these functions that you can use to make your static HTML look pretty. The other thing that we saw was that every output element has a corresponding render function that you should use to populate it or to fill it on the fly, right? So we saw a text output. If you have a text output, then you should probably somewhere in your server section, you should have a render text. Otherwise, there's not going to be anything inside that output element. And as we just saw through the problem solving, the IDs have to match, right? Plot output, we saw that. Table output, that works pretty well. This is DT output if you want an interactive table. There's image outputs if you want images. And then if you do know HTML, you can use one of these UI output or HTML output. So, but the important thing is here that there's partners. And then when you load packages like Leaflet or Giraffe, there's some other ones. There are some additional UI elements, and those packages also have additional render functions that you can use to fill them. The render, when you do write the render functions, every render function expects a specific object that's produced inside the code that you work. And you can have lots and lots of code in your render function. The only thing that really matters is that last line, right? So here's an example of a render function for rendering text. And you can have thousands of lines of code in here. As long as that very last line of code returns, in this case, text, you're good to go. All right. But if you do want to have multiple lines of code, that's fine. Again, putting these little curly braces inside there, which kind of creates a unified code block that's evaluated all at once. Okay, so at this point, if you're like a lot of people, might be reaching for the Advil and wondering, this is a lot of details. Do I really have to learn all this? Can't I just ask GenAI to do this for me, right? That's a reasonable question to ask yourself in 2026. And of course, the answer is yeah, with some limitations. There are some really, really good Gen AI helpers these days, particularly with coding. I occasionally, I turn to all of these tools, these LLMs. I don't use Copilot so much, but Gemini, Claude, ChatGPT, they're all pretty good. I'm impressed with Claude and Gemini. They probably use those most. And I use them mostly in the browser. I ask a question like, how do I change the appearance of something? These tools can also you could put in there, make me a shiny app that will create a mortgage calculator or something like that. And it'll probably do a reasonably good job, right? So you can definitely use these tools. Another one that I might highlight here is called Shiny Assistant. I'll put the link here in the chat window. This is something that some folks at Pause have put together. What's cool about this one is I think it's using Claude under the hood, but basically you can give it a prompt and it'll generate a Shiny app script and actually run it right there. And then you say, well, can you move this thing over there? Or can you change the calculations this way? And you can basically keep asking it. It's going to keep tweaking it as best it can until it looks the way you want it to look, right? So that's Shiny Assistant. I think that's kind of a cool thing. Uh, you might be familiar with. There's a lot of these kind of Gen AI tools in integrated development environments. So RStudio, Positron, VS Code, these programs that programmers use all the time. They've got add-ons, they've got extensions. They can do things like as you're typing, you see some suggested ghost text, like how to finish that thought, how to finish that piece of line of code that you're working on. They have sidebar interfaces. I don't use these, so I don't have a lot of experience with them. It's kind of on my to-do list um, to figure out. But that's another way that you can use Gen AI, right? So these are three different ways that you can use these helpers, either just through the web interface, um, or integrated into your development environment. What I would say are some general best practices is, let's start with, only use the tools approved by your organization, and you only use them in the ways that are approved by your organization, which almost definitely is going to mean don't give it any potentially sensitive information. In general, I think in general, good practice is, a smaller question is probably going to do a better job at answering. It's probably going to give you results that are a little bit easier to evaluate. But that's my personal thought. Understanding the fundamentals is really important, right? So I'm trying to hammer in the fundamentals of how Shiny operates, how reactivity operates, so that when it gives you some code, you can kind of unpack it a little bit and kind of understand how it works. Does it pass the smell test? I would be very wary about asking Gen AI questions on a domain that you know nothing about, you have no ability to evaluate, and certainly not if it carries any consequence, right? Because you're just not going to be in a position to tell if it's a good answer. Asking the same question to multiple LLMs is another good practice. I will often do that, particularly if it's a niche kind of topic. And again, general good one is going to be, when you are in conversation with Claude or Gemini and you're asking it questions about programming, think about as having a conversation with an instructor and ask follow-up questions and follow the links to the documentation so that this is not just, it's a learning experience. You're not just getting working code, but you're actually learning and getting better as a programmer. These would be some of my personal best practices. I'm not deeply versed in using Gen AI for programming, a little bit behind the curve there. If anybody has any other thoughts, Genoa writes here, they're better at telling you where you made a mistake than generating. Yeah, good point. In general, error troubleshooting is something that they're good at doing as well. Okay, let's go to our next app. Let's see, we got maybe 35 minutes to go. This is going to be similar to what we just did. So we're going to build upon what we just developed, the Penguin Data Explorer. But there's two new pieces here, right? So we already have a drop-down box for the species. And then we're going to add another drop-down box for the island, right? So that's going to be a filter as well. And then we're also going to add another input, which is going to be a slider. And then this is, so you can see that here. And this is also going to be used as a filter, but it's basically going to create a random sample, right? So what we see in the scatter plot and what we see in the summary stats table isn't going to be the whole data set, unless you say use 100% of the data. It's going to take a random sample, all right? So these are some like little modest additions to our app. And then this is what the reactivity diagram that we're going to build looks like, right? So before we had a single select input. Now we're going to have two more of those, right? So we're going to have one for the island and then that slider for the percentage. And then we have the same two outputs, but then we have this purple thing in the middle, right? So let's talk about that. It's not really critical here. We could have, arrows going to all, like three blue arrows going from the inputs to the outputs. But what this thing in the middle is called a reactive. And a reactive uh, is really, really common once you get beyond the beginning apps. And basically, you can think of a reactive as an object in R, right? Like a data frame. Any kind of object can be saved as a reactive. So a reactive is you create it with the reactive section, but what the way you define it is not like it's not like assigning it a literal value and like using a function like you define a reactive with the snippet of code, and that when that snippet is code is evaluated, it returns something. All right. And the snippet of code should have references or should use input values or values from other reactives, right? So a reactive object is part of the reactive change, right? So it updates when it needs to update, and it's defined by a piece of code. And one of the reasons we use reactive is to eliminate duplication. All right. So if I go back to our diagram, we could have um, we could have a line going directly from the species and island inputs into the plots. It's basically a filter process, a filter operation. And filtering a couple hundred rows in a data frame is milliseconds. But imagine that operation took a lot longer. Then that duplication would be wasteful, right? Because we're basically filtering the same, but according to the same values, whether you're generating a scatter plot or a summary table, you still have to filter it. So why do it twice? More significantly here, though, is that the randomizer. So by taking a random sample, assuming that you want the scatter plot, the rows in the scatter plot, to match the rows in the summary stats, right? To those outputs to be drawn from the same data set, then you don't, they wouldn't be the same if it was drawing a different random sample each time. So this reactive element in the middle, it's basically, you can think of it as like an intermediate object, and it's duplicating, it's eliminating some duplication because we only have to filter once. And here's an example of creating a reactive object. This is really, really similar to what we're going to be doing here. But basically, it's reactive it's reactive specifically because it's using, in this case, an input object. All right. Which means whenever that input object changes, because the user selects something different, that this reactive element's going to be reevaluated. All right. Now, how do we use these? So you basically use them like you would an R object, like a data frame. But because they are dynamic, then you call them like it's a function, right? So here's an example of a little piece of render table code that's using that reactive that we just looked at. But notice that we're calling it using, we have parentheses after it, which is a reminder to us that what we're, that this data frame, it's actually dynamic, right? We're calling it like a function. So reactives are almost always used somewhere else in your app, right? There's no point in creating it unless you're going to like use it in an output or to update another reactive, or maybe when you're exporting something. You can chain reactives together to create a data processing pipeline, which is fairly common, I would say, particularly if the intermediate stages of that processing, you want to save those for something or use them for something. And reactives can be bound to specific events. So right now, the reactives that we're creating today, they're going to be live all the time. So whenever that species value changes, it's going to update immediately. Sometimes you don't want that reactivity to be immediate. Sometimes you want to control it. So that's what this is in reference to. We're not going to get to that today. It's slightly more advanced, but it's not too hard. Okay, so let's go back to RStudio and Posit Cloud, and let's build this, right? So again, we're going to build this Penguin Data Explorer Part 2, right? So we're going to add the input for the island, and we're going to add a slider for the percent sample. Let's start with that. All right, so go back to RStudio. You can go ahead and close the one we were just working on. Feel free to save it if you'd like. You'll notice, of course, that the answers, the solutions, so to speak, of these, each of these is already saved here as well. So click on exercise 1, app2_start. This is what we're going to start from. So again, go back to RStudio and open exercise 1, app2_start. And let's go ahead and run it. So I'm just going to open it and click run and see what we got here. So it looks, I don't get any error messages, which is always nice. So it's basically where we left off for the first exercise. You change the species and it's going to update the scatter plot and the summary table. Okay, so let's go ahead and let's take the next steps on this. So to add a select input for the island, this could almost, I'm going to pause here and ask you guys to do this. You should be able to do this, right? So your challenge is, if you're following along, is to add a select input element to your user interface and maybe put it right below the species select input. Right, so that's a challenge. Yeah, so the challenge is to enter or to add a select input for to the user interface. You could call it in_island, for example. And you might remember there's a column in the penguin's data frame for the island. So I think there's 3 islands that these penguins were measured from. So it should show the names of the islands. I'm going to pause for 2 minutes and let people noodle on that, and then we'll keep going. Okay, so our challenge, our task is to add a select input to the user interface. So the way I'm going to do that here is I'm going to put it right below the first select input for the species and basically follow the same template. So we can add one by adding another select input function. And then first argument will be an ID value that we can use to refer to this one. So I'll call this in_island. Okay, the next argument will be the label. So island is a good label for a list of islands. And then choices is going to be the next argument. And then for that, we want to get the penguins $island. But of course, that's 150 of those. So we have to wrap that in unique, just like we did with the species. Try to spell that right. All right, and then to see if it worked, I can go ahead and hit Control S and run. And yes, I do see another drop-down box, right? So let me put that in chat for those who are following along. Okay, so next, let's add a slider, right? Below that, let's add a slider that we can use to get a random sample of the observations for the scatter plot and the summary set table. So let's do that together. So I'm going to put a comma here because we'll stick it below the select input we just created. And to create a slider input, you can probably guess it's going to be the function that we're going to use is called slider input. All right, and I'm going to call this one IN and then PCT. And then the label I'm going to give it will be percent sample. And if you look at the little yellow help box, other arguments that I can use in the slider input function to create the slider will be the min, the max, and value. Value is kind of like the initial value. All right, so let's go ahead and say the min will be 10, max will be 100%. The initial value will be, let's say 50. And then the step will be, instead of, I'll make the step 5 or 10. Okay. And let's go ahead. I'm going to save that and run it and look for errors, no errors. And yes, I do see a nice little slider, right? Now, of course, the island drop-down box and the percent sample have no effect yet because we haven't changed anything in the server section. But the user interface parts look good. So let's come down now and wire them in to the logic of our app. So as I mentioned before, the way we're going to use them is we're going to create kind of an intermediate object. We're going to create a reactive object, which represents the filtered data. And that's going to be a reactive object, a new reactive object. And then we're going to feed that into the render functions for the plot and the table. All right, so but first of all, let's go ahead and create that reactive object. All right, I'm going to type it here by hand, but then I'll put the code in the chat window here, just so you kind of see how you create a reactive object. It's not hard, right? So we give it a name. So we'll call this penguins. I'm going to call it, I've already used penguins underscore still. Let's call this penguins underscore sub. That's meaning the subset. And then I'm going to say this is I'm going to assign it the results of the reactive function. And again, I'm going to use, inside the reactive, I'm going to use the curly braces so I can have multiple lines of code in here. But the end of it, the very last expression in this block of code should be a data frame, right? That's because that's my goal, is to get a data frame, right? So this is going to be pretty easy. It's simply penguins, and then that's the unfiltered data frame that comes with R, and then we'll pass this through filter, and we'll call it species value double equal sign input $ in underscore species. And then the second expression in the filter function, this is the new part, we'll say island, right? So there's a column called island, double equal sign input $ in island. All right, I think that works. Okay, so that bit there takes care of the filter from the species and the island drop-down boxes, but then we also have that percent sample. So for that, I'm going to pipe this into, there's a cool little function from dplyr called slice underscore sample. And then here, as you can see in the little pop-up box, we can slice underscore sample. We'll take a sample of the rows. And then you can either feed it n, which is like a number of rows to select, or prop, which is the proportion of rows to select. So we'll use prop, and prop is going to be input $ in PCT, right? So that's going to be PCT. That's going to be a number between 10 and 100. And then so to turn that percentage into proportion, we divide by 100. Okay. All right, so I'm going to save that and run it. And I'm just running it to see if I get any error messages, right? I've got this reactive object now, and it is updating when necessary, but right now it's not necessary because we're not using it yet. We haven't wired it into those render functions. But everything's looking good. So the last step to make this this new reactive object part of the reactivity chain is to use it in my render functions. So this is going to be really easy to do. So I come down to I'll put this in chat here. Those of you who are following along. Okay, so that little snippet of code in there creates this new reactive object, which is basically the live dynamic filtered penguins data frame. So next we want to use it in the render plot piece. So I'm going to go to render plot, and I don't need to filter render. I can take out the lines of code that filter the penguins, because now we're doing that in the reactive object. We don't need to filter them in the render plot expression. So all I have to do is replace penguins filt with penguins underscore sub, and remember to put in the parentheses, call it like a function, right? So once again, I'm modifying the ggplot statement, and I'm using the reactive object that I just created. And I'm going to do the same thing for the summary stats table, right? So the summary stats table, I still need to group it by sex. So in the summary stats table, I still need to use group by and summarize to get the summaries, but I can pull out the filter expression and instead use the reactive. All right. So let me go ahead and put these in chat here, folks who are following along. All right. Okay, now let me save it and run it and see how it looks. All right, I'm going to make this a little bit wider so I give myself a little more screen real estate. So now when I change the percent sample and I bump it up, yes, when I bump it all the way up to 100, I can see looking at the Adelie penguin species on Torgerson Island, I can see there's about 50-ish observations, and when I drop it down to 25, indeed, I'm getting fewer points. So it seems like it's working, right? So we're getting both, we're getting filters both from the island as well as this new slider that we created. All right. All right. Any questions? Okay, I think we're basically done with that project. Let's go back. Yeah, so we're coming down to the final few minutes here. But just to review what we did there, Again, whether you were doing all the hands-on or not, basically we added a reactive element object to our application. And this is kind of this is really useful and pretty common. So you can use one of these reactive objects. And again, think of it as like a live dynamic object. Very, very common. This would be a data frame that you're using, but it could be anything. It could be a list, it could be a spatial object. Whenever you need an intermediate object and kind of like the logic of your decision model or your application, this is a good choice. They can literally just store anything. And you can just, yeah, and then once you create them, you can use them anywhere, right? You can create chains of reactives, and so forth. All right. So we're gonna kind of stop there for our intro to Shiny. We have time to do I'll do a couple slides on decision support tools more specifically, but in terms of the programming techniques, we're gonna stop there. There is more though. There's quite a bit more. There's ways that you can control reactivity. So like I was saying, right, what we've done so far, reactivity is automatic and you can't stop it, right? You change a slider, things are going to update whether you want them to or not. But you can imagine another kind of web app where maybe there's like 6 or 10 settings that control what the user sees in their output. And you don't want them to update all the time. So you can throw in like a button that will kind of control the reactivity except when they put that button. That's called binding the event. So there's different ways that there's different strategies, programming techniques that you can control the reactivity. You can also set up something called an observe. And this is again, it's reactive, right? You put it in your server section, and it's a chunk of code that runs when needed, but it doesn't return anything. It doesn't like populate an output object or something, but it does something else. Maybe it calls an API. Maybe it does some stuff with files on the server, and so forth. All right, so you can do those. Reactive vals, that's another kind of reactive object. It's real similar to a reactive, but you can update it from different places, right? Whereas the reactive that we just created, it is created by a little piece of code and only that little piece of code. There's no other way that you can update a reactive other than rerunning that little piece of code that you use to define it. With a reactive val, you can update the value of a reactive val object in different places. And then there's also, just like there's a series of render functions that changes the output objects, there's also a series of update functions that you can use to update the label or the choices or the default value of your input elements, right? So there's more stuff that you can do to control kind of that user experience, right? But what we got covered. Let's talk a little bit about publishing, right? Because a lot of people are interested in publishing their work. And that is a big advantage and appeal for Shiny. So you do need to publish it if you want it to be available to anybody with a web browser. If you want it to be available to other R users, you've got some more options there, right? You can run Shiny apps off GitHub. You can put them in packages. You could send somebody your app.R script and they can run it, right? But if you want the general public to have access to it, you have to publish it or share it on a server, obviously. RStudio has made this pretty easy. There's a big old publish button. And when you click that, you'll see it on the same, right next to the run app button. And when you publish it, after you've set up your shinyapps.io account, it takes about 5 minutes, but it gets published. And then you can send it to your friends or your family members. And that works pretty well. Shiny Apps does have a free tier. So there's some limitations to how big and complicated your Shiny app can be. That's a good choice. Posit also has another platform called Posit called let me go to the next slide, which talks about some of the other hosting options. So Shiny Apps.io, unfortunately, Shiny Apps is going away in the end of this year. It's an older service that Posit developed. back when they were called RStudio. But it's being replaced by the new platform, which has more features called Posit Connect Cloud. That one also has a free tier on it, so it's more or less equivalent to shinyapps.io. There are some differences though. Posit Connect Cloud is designed to be deployed from GitHub. So in other words, you commit your Shiny app folder to GitHub, and then you push your changes, and then you go into Posit Connect Cloud and you give it permission to get into your GitHub, and then whenever you publish an update, the app gets updated on Posit. So a slightly different workflow, but shouldn't be too onerous once you've got it set it up. There are some commercial services. Posit, of course, has paid versions of all of their products, including Posit Connect. That's an on-prem server product that they serve. You can also, if you have some server development skills, you can fire up a preconfigured server on AWS, on DigitalOcean. I suspect Azure has the same one. If you know Docker, you can put your Shiny app into a Docker container that's got the Shiny server open source, and then host that on any platform that can host containers, and so on and so forth, right? But the easy ones are going to be that publish button that you have in RStudio or in Positron. Something else which is pretty exciting and cool, I played with it but haven't used it a lot. You can actually, again, bundle up your Shiny app using a package called Shiny Live with a version of R that actually runs entirely in the browser. And what this means is that you don't have to publish it on a server that's running Shiny server, of which there aren't that many, right? As we can see here, there's just a small number of those. But if you run it in Shiny Live, you can really publish it on any general web server, like any Apache web server could host it. There are some limitations, because again, now your browser, it's not just running your user interface, it's actually running R all within the browser, right? So that's a lot more demand on your browser. There's limitations, but certainly makes it more flexible to host your Shiny app other places. All right, well that's not bad timing. We're just at 4 o'clock here. So I'll pause here and take questions. So I wasn't expecting us to get to part 2. I think that's going to have to be a second workshop. But that's where we're basically going to take a decision model and actually go through the process of turning it into a real decision support tool. We'll talk about what that actually means from Shiny perspective. But if you're interested in that, let me know, or you can just kind of like peruse the slides. Otherwise, I'm going to stop here and say thank you to everybody for being part of today. We do have a little bit of a evaluation. So before you go, if you would be so kind as to fill in this evaluation, this will let me let the powers above us let us know that these workshops are valued. And also, this is the first time I ever taught this workshop, so all your feedback would be really, really helpful. Okay, otherwise, thank you everybody for coming today. I will hang out if anybody wants to nerd out on anything related to Shiny or R or data, and enjoy the rest of your day.